Welcome back everybody to Geology 101. So in this section we focus on glacial erosional landforms, like one we see in the picture here, Matterhorn. So in our first unit we covered actually these first 3 unit goals here. What is a distribution of glacial ice on the Earth's surface? How do glaciers form and how do they move? And what are our basic types of glaciers and the relationships they have to one another? And the whole rest of the unit is dedicated to this last objective here. What is the role of glaciers in shaping the surface of the Earth? So how is it that glaciers shape their environments? Well, we'll talk about our 2 primary ways here. First is through sediment transport, aka erosion, and the second is through the mechanical weathering process. Now, throughout the unit here, and maybe for the rest of the year, you'll hear me use the word erosion sometimes to mean weathering and erosion combined, sort of a broader use of the term. Don't be bothered by that, even though we did have that strict definition for erosion before. Okay, so we have 2 primary methods to consider here. The first is where we have this sheet of ice. It moves across bedrock. And as it moves across it, it rips up these big boulders, big chunks of the bedrock, and incorporates them into the ice body, transports them elsewhere. Later, the glacier melts, and that boulder is left behind. This is a process known as plucking, right? It is plucking up these sediments, these very, very large sediments, out of the bedrock as it flows over them. The other process is more of a smoothing process, something called abrasion, where we have all of these different little chunks of rock which are caught up in the glacier. And so as the glacier moves over the surface, it smooths it out or even scratches it a bit, like sandpaper. Okay, so we've talked about the different processes that shape these environments. Now let's go to what the environment actually looks like. We have our type example here, mountain range, the Swiss Alps. And what exactly do we see? Well, there's a couple features that stand out right away. We have these very, very sharp ridges, sort of spiny looking things, very, very sharp corners almost. And whenever you have these meet, you have a sort of pyramid shaped peak to the mountain. And we also have these little features that almost look like bowls, like somebody could sit here if they wanted to, that are carved out into the mountain. And well, let's go ahead and look at a diagram really quickly. So we have our pyramid-shaped peak. We have these various seats, which may or may not have lakes in them, spill out into rivers and move down the mountain. We have all of these different sharp spines that make up the area, and wherever multiple spines meet, we have the peaks. And then finally, we might have these different valley systems. So this might be a smaller valley here with a smaller glacier that feeds into a larger glacier here, a larger valley. And actually, whenever you have a smaller valley that ends in a larger valley, cutting it like this is called a hanging valley. As far as the particular shape, unlike our rivers and the V-shaped valleys that we saw here, these, you could tell the difference is going to be U-shaped. So if I showed you an environment, we went somewhere, we had images of what it looked like, you could actually look at the shape of the valleys and tell me which forces were most important in shaping that environment. Alright, so now let's throw the vocabulary in. The first thing we'll want to talk about here are the arêtes, right? We have these spiny ridges, which are a result of glacial erosion. Right? You might imagine there was a glacier on this side at one point, and a glacier on the other side eroded everything away, and we're left with only this sort of sharp, pointy ridge. Now, whenever you have multiple arêtes that meet in the same place, you have this sort of pyramid-shaped peak to the mountain, something called a horn. We also have these bowl shapes, right? So the same way that we looked at those cirque glaciers, these bowls are going to be called cirques. If there is a lake in the middle of the cirque, that's going to be called a tarn. Now, we also have valleys. Maybe this was carved out by a valley glacier at some point. And, well, we can tell that this one was a subsidiary glacier body to whatever the bigger glacier was here, right? We have a valley that comes up here and ends as it's cut by a bigger valley, something called a hanging valley. If we looked at the shape of it, it is going to be a U shape. Okay, so definitions. Whenever we have a glacier, right, you imagine we have a glacier here at some point, and as it moves down, it's going to erode everything on the sides and result in this sort of a chair shape or a bowl shape. You might hear it as seat shape. So this is going to be the cirque here, is actually the bowl shape of the rocks themselves. In the middle of the bowl shape is going to be this lake, which is called the tarn. So the cirque is like the seat, and the tarn is going to be, well, whatever sits in the sea. So our next feature is a horn. You imagine, okay, in the past this was a full-out regular mountain here, but we had a cirque develop on one side and carve it out, and a cirque develop on another side and carve it out, and another one on the back side develop and carve it all out. Bowls on every side, and the only thing that is left is this steep horn of a mountain, and this is actually called Matterhorn in the Swiss Alps. You can also think of this as the meeting of several ridges here, or several arêtes. Okay, so we might try to go back in our minds and imagine that at one point these were more full-bodied, a little bit less steep mountains here. And over time, as glaciers come through, valley glaciers, and start to carve away the sides, only the very steepest stuff remains, these steep ridges called arêtes. So we could look, we could actually draw in where they are for the entire diagram here. Also tend to be very, very popular things to climb if you are a mountain climber or a rock climber. Okay, so we talked about this process of abrasion. We have some glacier ice body, and it incorporates all of these sediments into it. So whenever it moves over a body of bedrock, it actually scratches the rock. It's like sandpaper. And the gouges, the grooves that are left behind, are called glacial striations, these lines here. So if you came to an area that has no glaciers whatsoever, you'd see not very many glaciers here, you would look at these lines in the rock and know that there were glaciers here at some point. Okay, so our last feature to consider here. I show you an image like this, or maybe you look at something in Google Earth, and you have to ask the question, well, was this valley carved by the river in the center here, or carved by a glacier? Well, you could figure this out by using the U shape of it. Rivers are going to carve the V-shaped valleys, glaciers are going to carve the U-shaped valleys, and likewise for here. Right? You ask the question, is it a river or is it a glacier, and the shape of the valley is what gives it away. So for this previous section, we've talked all about what happens whenever you have glaciers that are ripping parts off of the environment and carving it out and moving things elsewhere, all of these erosional landforms, taking things away. On the other hand, glaciers also do a lot of sediment transport and deposition, moving rock from one place to another and depositing it to build stuff. And these are our depositional landforms that we'll talk about in the next section.